Let's have an explanation break now. So what I want you to do is to go to your partner and explain what do babies know about people at birth, at 9 months, and at 18 months. And we'll take 3 minutes to do that. Okay, good. People are making friends too. Okay, so far what we did was we were describing all the different stages that babies go through in understanding people's minds. And what we saw was that even from the time they're born, even in that very early period, babies aren't blank slates. They already begin by knowing some important things about people and how their minds work. And even during infancy, though, they seem to be learning more about how people work and making inferences about how people work. And really, the great big question for developmental psychology is what happens? How do they learn it? Why do things change from 3 months to 12 months to 18 months? So what's happening in terms of babies' minds that's actually enabling them to learn as much as they do? And I think it's a fair description to say for a long time, most of what we were doing was actually charting, here's what babies know when. And it's really only been recently in the last 10 or 15 years that we started thinking more deeply about how is it that they could possibly be learning. And I'm going to talk about 2 ideas about ways that babies could be learning about the world. And they're also interesting because both of them suggest that babies are in fact learning about the world. After all that, on the innate modularity view, you might think, well, these changes aren't the result of learning. It's just that the baby's brain is maturing and getting more sophisticated, so the baby's a different baby at 3 months or 8 months or 12 months. So the first question really is, are they even learning these abilities? And secondly, of course, how are they learning? What kinds of things are contributing to their learning? And I'm going to talk about 2 different ways that you could think about the baby's learning. One way that babies could be learning is through their own actions on the world, through appreciating what it is that they do out in the world and consequences that has, and then taking those things that they find out from acting in the world and applying them not just to themselves but to other people. Yeah? Here's why it's not just like operant conditioning. So let me backtrack for a little bit. So I just said we've only recently been starting to think about babies learning. That's not quite true. Way back in the battle of behaviorist days, people did think about babies learning because they thought about things like operant conditioning and classical conditioning, kind of good old-fashioned classical ideas about learning. But both of those, and when we were talking about the kind of empiricist views, an example of an empiricist view theory would be everything that babies learn, they learn through operant conditioning or through classical conditioning. Famously, B.F. Skinner was a famous psychologist back in the 50s who wrote books in which he said everything that we learned, babies and children and adults included, just was the result of our history of being conditioned, just the way that pigeons could be conditioned. And there is a possibly apocryphal story that he actually raised his baby in a Skinner box where the baby was being reinforced for doing some things and not being reinforced for doing other things. And by all accounts, the baby didn't grow up to be a particularly sane adult. But this may be, I'm not sure we have complete good historical evidence for that. Now, operant conditioning is the idea that when babies do something and they're reinforced, then they'll be more likely to do that again. Classical conditioning is the idea that if babies see one thing happen, they associate it with something else. So if they hear the bell ring and food comes, then they start to anticipate the food with the bell. In operant conditioning, it's that if they press the lever and then the food comes, then they're more likely to press the lever to get the food. So those are very, very simple, primitive kinds of learning. But the kind of learning I'm going to talk about now is actually quite a bit more sophisticated. So we could learn, that's actually a good setup to what I was going to say, we can learn from action in this very simple operant conditioning way, like a pigeon or a rat. But of course, if you think about, say, doing experiments as a scientist, that's a kind of learning from action. So when I do an experiment, what I'm really doing is I'm going out and doing things on the world, I'm seeing what happens, and then I'm drawing some conclusions about how the world works on that basis. So you could think about this kind of learning from action as being more like going out and doing experiments than it is like just repeating the actions that you've been reinforced for. Thanks, that was a helpful question. Okay, so a lovely experiment about this, just one of many, shows the fact that, remember the Woodward experiment? Okay. I mentioned that 7-month-olds actually solve this problem, but babies younger than 7 months don't seem to solve this problem. So if you do the same experiment with, say, 3 or 4-month-old babies, they won't look any longer at the second one than they will at the third one. So that suggests that babies are learning something that might make a difference to their understanding of people's goals. And in this beautiful, very, very elegant experiment by Jessica Somerville, what she did was to use something called sticky mittens. And the way that sticky mittens work is that they're little Velcro mittens that you can put on the baby's hands, and then you attach Velcro to little objects that are on the tray. So what that means is that the baby can actually go out and reach something. And mostly, if you see 3-month-olds, they're not very coordinated, they don't have very good grip, so mostly they can't actually manage to reach things and bring them to themselves. Mama has to basically give them everything. But if you put the little sticky mittens on them, then they're sort of like super babies. All of a sudden, they can do this amazing thing, go out and reach for something and bring it to them, which they couldn't have done without the sticky mittens. So what Jessica did was she gave 3-month-olds experience with the sticky mittens. So they actually had a chance to practice using the sticky mittens. And then she gave them the habituation experiment. Then she gave them Amanda's experiment about the bowl and the teddy bear. And what they discovered, quite amazingly, was that the babies who had sticky mitten practice did much better on this task. So now a 4-month-old who before wasn't differentiating between the second and third slide was differentiating. Now even a 4-month-old would prefer to look at the one that was about the action as opposed to looking at the one that was just the movement. So it seemed as if the experience of knowing, seeing for yourself, oh, I see, I want that one, and then I put my hand out and I can get it, actually meant that the babies would then say, oh, okay, now when I see this person in the video or in the slideshow reaching for it, that must mean reaching, that must mean that they want it. Look, I've just had this experience of when I want things and I reach for them, I can actually get them. So this is a really elegant experiment showing that babies using their own action to get these contingencies, in effect doing this kind of little sticky mittens experiment, sort of like suddenly giving the babies a telescope so they could find out things that they couldn't find out before, or an NSF grant. That was actually enabling the babies to find out about things that they couldn't have found out before. And then the things that they found out just by experimenting on the world, they then applied, equally interestingly, the things they found out about themselves from experimenting on the world, they then applied to other people. So having these experiences themselves made them understand other people in a new way. Yeah? Oh, that's a good point. No, it's just a hand. It was just exactly the same experiment. So now they seem to think even if you didn't have sticky mittens, you would reach for the objects. So these are the sticky mittens super babies. And there's a baby actually swiping at the objects with the sticky mittens, 3-month-old. Sort of amazing. Okay, so one way that you can learn is you can go out and you can do experiments and you can learn from experiments. If you're thinking about the babies the way I tend to do as little scientists, another way that you can learn is from looking at statistical patterns in the world. And one of the really amazing things that we've discovered over the past 15 years or so, something I would not have guessed 20 years ago, is that even very young babies are actually extremely good at understanding statistical patterns. And in the book they describe a whole bunch of studies that suggest that babies are good at understanding statistics. So even concepts that are very hard for adults to understand, like probability or a relationship between a sample and a distribution, those are things that we have some evidence that babies can actually understand. And let me give you an example of this. This is an experiment done by Fei Xu in our department here at Berkeley. And here's what she did. So you might ask, what do you mean, how could babies possibly know anything about statistics? So what Fei did was she used this habituation paradigm that I'm talking about, and she showed babies a box full of balls, mostly red, sometimes mostly red with a few white, but sometimes mostly white with a few red. And then what she did was she showed the baby, the experimenter, either taking, put in the center.
See those? Look at that one.
So then what babies told her, they told her to take a sample out of that box. So now, for instance, she's taking out 4 red ones and 1 white. And that makes perfect sense if the box mostly has red,
Look
right?
at that one. See this one?
But now, what she's going to do is take mostly white ones and then 1 red one.
See that one? Look at this one. Look, baby. Look.
Now, wait a minute, right? If you've done your intro statistics class, what you should be thinking at this moment is less than 0.05 probability that that happened by chance, right? You should be thinking highly significant event. Something else is going on. This wouldn't just be a random event. Now, notice that it's not like this is impossible. It could happen by chance. It's just that it's way down in the tail of the distribution, less than 0.05 probability that it did. And what they discovered was that 12-month-old babies were making the same inferences. So if they saw they were more surprised. They looked longer when there was a mismatch between the sample and the distribution than when the sample and the distribution matched. So the babies were more surprised by look longer in this sequence of events than in the sequence of events that I just showed you. Well, what does that have to do with the baby's understanding about mind? Well, here's the next experiment. This is an experiment that a Berkeley student, Tamar Kushner, and Fei did to try to see if babies might use that information to actually figure out what was going on in somebody's mind. So what they did was combine that experiment with the boxes with our broccoli and goldfish experiment. And the way they did it was they showed the baby a box full of green frogs, and the experimenter takes 5 green frogs out of the box of green frogs. Now, of course, the thing is, there's nothing else you can do when you see a box of green frogs except kick green frogs. There's no other option. And I love these videos because you can see how intense the babies are. Yeah. If that baby isn't thinking, you and I know what thinking is. All right, now she gets a choice. She could give the experimenter the frog.
Sydney, oh goody, just what I wanted. Can you give me one?
All right, now here's the question. What should you give her? Well, the truth is, you don't know what to give her. You don't know how the experimenter feels about the ducks, right? All you know is that she picked the frogs, but she didn't have any other choice except picking the frogs. And in fact, what the choice is to give her the frogs half the time and the ducks half the time. But now here's the other condition. Now here's another adorable baby. But now it's a little different, right? The only difference is that now there's mostly ducks and just a few frogs. So now the experiment is going to do exactly the same thing, pull out the green frogs. Except now, if the baby's doing that statistical analysis that she was doing before, the baby should be that couldn't have been a random event. She wouldn't have just randomly have picked out all the frogs. It's kind of like, the rock star insisting that you only get the black jelly beans, picking out the black jelly beans from the jar of jelly beans, right? It must be that she likes the frogs.
Oh, come in. Hi again. Sam, oh goody, just what I wanted. Can you give me one? Oh, thank you. Thanks. Give me another one. Thank you. Good job. I like that. Good job. You have back their balls? Remember that last time? I have a new toy for you.
Okay, so those are really cute babies, but it turns out that they were actually pretty typical of all of the babies that they tested. So these 21-month-olds were using the statistics to figure out what it was that somebody else wanted. And they did that in other experiments. Fei has shown that even younger babies, even 15-month-olds will do it. And literally, as we speak in our lab, what we're doing right now is trying to see if we take the 15-month-old babies who are always giving you the crackers and we give them lots of experience like this. So we give them lots of training of seeing people picking out different things. Will they switch to thinking, oh, I see, actually, people could want something different. And I'll tell you how that experiment works out, hopefully by the end of the semester. We should know in a couple of weeks. Okay, great, thanks. So the main point is that babies know a lot about other minds to begin with, and also that they learn a lot, and they learn a lot by doing experiments and doing statistics just the way we do as scientists.